right? So we start with chapter 2 with the partial derivative with application. So before we start lecture on chapter 2, any questions regarding the previous lecture? Any question, class? No?
No question on metrics.
Alright, thank you. So if no question, then we continue on this lecture. Okay, I hope that you can see the slide. Okay, so for this chapter 2, we will learn about the partial derivative with application. Okay, we will look at some application that related to the engineering that we can solve by using the partial derivative. All right. Okay, so in this partial derivative part 1, we have divided into 4 parts. Okay, so which is multivariable function. Okay, we have the partial differentiation, multiple differentiation, and implicit differentiation. Okay, so I hope today we can finish up to 2.2. Okay, variable function and also the partial differentiation. If we have more time, then we can continue to the multiple differentiation. Okay, so first we look at what is multivariable function. Okay, so there are many function depends on more than one dependent variable. Okay, so for example here you can see that this is a cylinder, right? Okay, so this one is the cylinder. How to find the volume of the cylinder? Okay, so volume of this cylinder is pi multiply by this surface. Okay, pi r squared multiply by the height. Okay, so we get the volume. Okay, the area multiply by height, we get volume. Okay, so you can see that here this volume is depends on the radius and height. Okay, so if you have a cylinder, okay, so for example, this is your cylinder. So if you increase the radius, okay, so if you increase the radius, means that it's getting bigger. So it will affect the volume of this cylinder. Okay, and of course, when you increase the height, okay, you increase the height of this cylinder, of course, the volume also will be increased. Okay, so here we can say that the volume of this cylinder is depends on radius and height. Or in a function form, we can say that the volume is equal to the function of R and H. Okay, so from here we know that the volume is depends on the radius and height. Okay, so each function has its own domain and range. Okay, so what is domain, what is range? Okay, so for example here, okay, you can see that the function, for example, function of w, it depends on these two variables, which is y and x. Okay, so how we can determine which one is domain, which one is the range? Okay, so domain is the variable along x-axis, means that the value that you can substitute into the function. Okay, while the range is all the possibilities output of the value. Okay, range is all the possibility output value. Okay, so domain, which are the value that you can substitute into the function. Okay, that that the value you have to ensure that it's valid the function. Okay, you cannot substitute the value that is not valid to the function. Okay, for example here, you know that you have a function of w equal to square root y minus x square. Okay, so under square root, you cannot have the zero value, isn't it? Okay, so in order to have the zero value, okay, so this x should be equal to y. Okay, so we know that uh, in order to get non-zero numbers here, y should be greater than x square. Okay, so this is how you put the value of domain. Okay, so when you substitute all the values of domain, you will have a set of um, range. Okay, a set of the output. So this output we call it as range. Okay, so that's the difference between domain and range. Okay, domain, again, I said that all the value that you can put or you can substitute into the function, and the range is all the possibilities output that you can have from the function. Okay, so in this table it show you the function with two variable. Okay, you can see that x and y here is your variable, but in this table you have three variable, which is x, y and z. Okay, so here in this table you have three variable, in this table you have two variable, right? So that about the multivariable function. Okay, so how about the limit of the multivariable function? Okay, so we can say that the function of f is approached to the limit L as x and y is approached to a and b. Okay, so let's look at into this function. Okay, so this function, it contain of the variable x and y. Okay, but it has limit for x and y approaching a and b. So means that a is the limit x is the limit to a, and y is the limit for b. Okay, b is the limit for y, for example, right? Okay, so it's equivalent to the um, limit here. Okay, for example here, okay, you have function x minus xy plus 3 and x divide by x square y plus 5xy minus y cube. Okay, but you can see here you have a limit of x, y approaching 0 and 1. So x is equal to 0 and y equal to 1. Okay, so these two values of your variable you can substitute into this equation. So you can have 0x minus 0 multiplied by 1 plus 3 divided by x is equal to 0 squared multiplied by 1 plus 5 multiplied by 0 multiplied by 1 minus 1 cube. Okay, equal to minus 3. Okay, so when you substitute everything, so you will get the answer is equivalent to minus 3. So this is how you determine the limit of the function that you have. Okay, so let's look at example B. Okay, so you have a function of x squared plus y squared and the square root. So x is a limit to 3 and y limit to negative 4. Okay, so when you substitute, you will get the value of 5. Okay, something like that. This is how you substitute the limit into your function. Okay, so I believe that you already familiar with the function. Okay, function, differentiation, right? So this is all about the derivative. Okay, in chapter 2 about the derivative. Okay, so what we want to derive? We want to derive a function. So we must know how to read the function, what meaning by function. Okay, so for example, previous previously, you are given a function but in term of variable. Okay, so you know which one is a constant value, which one is the variable value. Okay. Right. So you may try this take home exercise 1. Okay. So let's look at this question 21. Okay, question 21. You have a function 1 over x plus 1 over y plus 1 over z. Okay, but you have a limit p 2, 1, 3, 4. Meaning that x equal to 1, y equal to 3, and z equal to 4. So all these three variables you substitute into this function. So it's equivalent to 1 plus 1 over 3 plus 1 over 4. Okay, so it's equivalent to 12, 11 over 12. Okay, something like that. Okay, for the rest, you may try by your own. Okay, so far any question? Can you hear clearly my voice or no?
Very clear, Miss.
Alright. Okay, so this is how to get the limit of the function. You have two variable and you also have a three variable. So you just substitute into the variable that you have. Okay, so the arrangement of the limit, okay, if it's said like this, so means that you have x, y, and z into the limit of 1, 3, 4. Okay, so this is the arrangement x, y, and z accordingly. Okay, when you substitute accordingly lah. Okay, so this is for x, this is for y, and this is for z. Okay, right. So let's continue to the partial differentiation. Okay, so how to calculate the partial differentiation and what are the fundamental behind the partial differentiation. Okay, so let's start with the simple derivative first. Okay, before we go to the partial differentiation, I believe all of you already know how to derive. Okay, how to differentiate a simple things. Okay, before we go into quite complicated mathematical problem. So let's try to recall back your memory how to do a simple derivation. Okay, so let's look at number 1. Okay, find dy over dx. Anyone?
0.
0. Okay, so why 0?
Because no unknown, it's only a constant there. So dy dx equal to 0.
Yes. Okay, so dy over dx is equivalent to 0. Okay, number 2. dy over dx.
2.
Y equal to 2x. X. Sure?
2.
2. 1x, 1, 2. Which one is correct?
2.
2. Okay, so when you derive with respect to x. So this is your constant. Okay, so the what we call the formula is y equal to ax, right? Okay, so means that here you find dy over dx is equivalent to ax. For example, here is n. So n minus 1. Okay, something like that. So this is the formula to do the simple derivation. So a is the constant. So for example here, 2 here is a constant. Okay, 2 is the constant. So you multiply by 2x. Okay, if nothing here means that the power is equivalent to 1. So 1 minus 1 is equal to 1 minus 1 is equal to 0, right? So 2x power 0. Okay, so everything that has a power or index is equivalent to 0, it means that is equal to 1. Okay, so x power 0 is equal to 1. So that's why here you get the value of 2. Okay, so when you derive 2x, you will get 2. Okay, so let's continue number 3. Okay, dy over dx. Y equal to x power square.
Two x.
2x. Okay, so this one supposedly that you have n here, right? So n multiplied by a times x to power of n minus 1. So same goes to here, you have 2x. Okay, 2 minus 1 is 1. So you have to x power 1 here. Okay, so x power 1 is equal to x. So it's equivalent to 2x. Okay, number 4.
12y square.
Dx over dy. Okay, you can see that here you have a function of y. Y in a function of x, but this one you have x in function of y. So you when you want to write down, it means that you derive x with respect to y. This one you derive y with respect to x. Okay, so this one supposedly to be 12 y to power of 2. Correct or not? Okay, so let's look at number 5. Okay, so 5, the function you have is u. Okay, u to power of x, 15x to power of 100 minus 3x power 12 plus 5x minus 46. Okay, find du over dx. Du over dx. Anyone?
1500 x power 99 minus 36 x power 11 plus 5.
Plus 5. Okay, so this one means that 100 multiplied by 15, you get 1500. Okay, x 100. Okay, use this formula, minus 1 to power of 99. Okay, minus 12 times 3, 30, 36. Okay, x to power 12 minus 1 here, power 11 plus 5. Okay, so this is your du over dx. Okay, so next is y equal to 15 times t power 3 over 2.
45 over 2 times t 1 over 2.
Okay, so dy over dt is equal to 15 multiplied by 3 over 2. Okay, multiplied by t. Okay, 3 over 2 minus 1 become 1 over 2, right? So from here you have 22.5. Correct or not? Itu kan? 45 over 2, 22.5, yeah. T to power of 1 over 2. Okay. So next, question 7.
At t
Du
plus
over dt. Again?
at t plus 12
8t plus 12. Okay, so from here, we find u over dt is equivalent to 2 times 2t plus 3 multiplied by 2. So you have 4, 2t plus 3, or it's equivalent to 8t plus 12, right? Okay, so the last one, number 8. Okay, if number 8, you find dy over dt is equivalent to, you take this power half, okay, multiply by everything inside the bracket. Okay, so you write down everything. 2t plus 6. Okay, so the power here you should minus 1. So it's become negative 1 over 2. And then you multiply, differentiate. You have to differentiate whatever inside the bracket. So for example here, differentiate become 12t power 3 plus 2. Okay, so this is how you differentiate, okay, a function inside a bracket, and then it has an index. Okay, so multiply index with everything inside the bracket. Okay, you write down everything, and then the power you should minus 1, and then you differentiate whatever inside the bracket. Okay, so this is if you want to simplify, then it's up to you lah. Okay, so if you want to left the answer up to here also can. Okay, this one we just to revise. Okay, so we just revise your knowledge on the simple derivative. Okay, so let's continue. Okay, we still have the question. Okay, we still have the question. Let's look at here. Okay, let's say this one is du over dx. Okay, sine, this one is involve a trigonometric. Okay, if sine x, when you derive, it's become cosine x. If cosine x you derive, you have to put the negative sign. So between derivation and another one is the integrations, right? So integration, it's reverse the sine and cosine. Okay, so you differentiate sine, you get cosine. Okay, you derive cosine, you get negative sine. Okay, so so number 11 is e to power of u. Okay, so if you have e to power of u, it didn't change. If you derive, if you integrate, you still get the same answer here. Okay, for example, you integrate e, well, let's say you have a function of e to power of y. Okay, so sorry, let's say this is a y equal to, or u lah. Okay, u equal to e to power of y. So when you differentiate du over dy, so it's equivalent to e to power of y. Okay, it's still same. Okay, but you have when you have 2 here, e to power of 2y. Okay, so you have e to power of 2y, and then you differentiate this to y. Okay, so it's become 2. Okay, so you have 2e to power of 2y. Right? Okay, so this one, t equal to e to power of 9. Okay, why the answer here is 0? Because here there is no variable. Okay, either you differentiate t with respect to x or y or any variable, but your function didn't have any variable. So it seems like you differentiate a constant. So if you differentiate constant, you will get 0 value. Okay, so this one is same what I'm explained here. Okay, so you can refer here. Okay, this one. Okay, e to power of 3x squared. Okay, when you differentiate with respect to x, so it become, so you differentiate 3x squared, so it's 6x to power of e multiplied by e, so you put everything. Okay, 3x squared. Okay, so this one is how you get this differentiation of this. Right, so another one is t equal to 3x squared plus 2x plus 6. Okay, so find dt over dx. Okay, so this one also same like previously, same like this. Okay, so you have you write down everything. So e to power of 3x square plus 2x plus 6. Okay, multiply. You differentiate everything inside the bracket. Okay, so you have 6x plus 2. Okay, so this is the same. Okay, so you multiply. Okay, everything inside the bracket. Okay, so let's say here you have x 1 over u, or u equal to 1 over x. Okay, so when you differentiate, you will get this one x 1 over x. If you change, it's become u equal to 1 to power of x minus 1. Correct or not? Okay, so this one, when you change, you will get 1 over x. Okay, when you change, you will get 1 over x. Okay, so when you differentiate here, du over dx, you will get negative 1 multiplied by x to power of negative 1, negative 1. So it should be negative 2. Okay, so when you rearrange into the fraction form, so it's become negative 1 over x squared. Okay, same like this. Okay, but when you do the integration of 1 over x, you will get ln x. Okay, so if you integrate, okay, but when you differentiate, you will get negative 1 over x squared. Okay, but when you have u equal to ln x, then it become 1 over x. Okay, when you integrate ln x, then it become 1 over x. Okay, right. Any questions, class? Okay. Okay, let's continue. Okay, why we need partial differentiation? Just now, we have the differentiation. We have the derivation. Okay, so why we need a partial differentiation? What is partial differentiation? Anyone know? Why we need this partial differentiation? Okay, so let's look at here. Normally online class, when I ask student, I also answer the question. That's a normal thing when we have an online class. I ask, I answer. Okay. Let's look at here. Why we need a partial differentiation? Okay, many function is depend more than one independent variable. Okay, like we have a cylinder just now, right? Okay, so this cylinder, it has a function of radius and height. Okay, so you may derive or you may do the differentiation with respect to the radius only. You also may do the differentiation with respect to height only. Okay, so this is why we need a partial differentiation. Okay, so for example here, okay, we have this kind of a shape. Okay, we have this kind of shape. This shape, you know, that is a function of x and y. Okay, so at here, okay, at this circle on the bottom surface. Okay, so the function is only depends on x and y. Okay, so x and y here is equal to 0. The function is equivalent to 0. Okay, when you goes inside, the function x y is equal to 75. Okay, so at the middle one, the function is equal to 51. Okay, so why you have different function? Okay, at this surface, okay, this surface we have another function which is z. Okay, so z here is equivalent to the function of x and y equal to 100 minus x square minus y square. Okay, so means that as you increase the x getting bigger or smaller, the y also getting increase or decrease. Okay, so it depends on the value of x and y. Okay, so this is another example of graph with multiple variable. Okay, so when you go deeper into a mathematical function, okay, you will see this kind of a graph. Okay, for example, here you have e to power of x and y, and then you multiply with the sine x and cosine x. Okay, so the graph will looks like this one. Okay, when you have z to power of x and y and you have another function of e, so the graph will looks like into this shape. Okay, so from this shape, how we can derive? Okay, how we can derive the function? Okay, so normally if you have this type of graph, we will do a partial differentiation. Okay, by using multiple variable. Okay. Alright, so don't look at onto graph. Okay, let's look at the function itself. Okay, so we start with the simple one. So how to do the partial differentiation? Okay, so let's say you have f. Okay, so f here is a function. Okay, so in this lecture, I denote f as the function. Okay, let's say I have a function of x and y. Okay, so it depends on the value of x and y. Okay, in order to find df over dx, okay, we let y as a constant and we differentiate x. Okay, so let's say I have a function of um, 3x squared plus 2xy. Okay, so I have this function. So how come I know that this function it has x and it also has y. So how I can get df over dx? Okay, so by using partial differential, it said that okay, um, in order to get df over dx, okay, so you should let y as a constant. So remember that when you differentiate constant, when you differentiate constant, it's become 0, right? Okay, so y here you treat as a constant. So look at the first term. First term didn't have any y, so means that you can straight away differentiate with respect to x. So it's become 6x. Okay, so plus. Okay, so for the second term here, you have variable x, you have variable y. Okay, by refer to here, it said that you have to let y constant here. 3 is a constant. Now y also you treat as a constant. Okay, so 2y now become constant. Okay, when you differentiate x, you will get differentiate x, you get what class?
1.
1. Okay, so when you differentiate x, you get 1 here. Okay, so this is how you do the partial differentiation of this function. Okay, so you have 6x plus 2y. Okay. Okay, so now when you want to differentiate with respect to y, so you let x as a constant and you differentiate y. Okay, for example, by using the same function here, you find df over dy is equivalent. This one, you treat as a constant. X now become constant. So when you differentiate constant, you will get 0, isn't it? Okay, so plus differentiate y, right? Okay, you want to differentiate y. So this term you have x and y. So x now become constant. So constant you write down. So you differentiate y is become 1. Okay, so the answer here is only 2x, right? So you can see now what's the difference between df over dx and df over dy.
Can you repeat the df over dy?
Again,
Can you repeat the df over dy?
okay. Okay, df over dy, we let act as a constant and we differentiate. Okay, let's say your function is equal to 3x squared plus 2xy. Okay, so this term, you have two terms here, right? Okay, so the first term, is there any y? No y, right? So when you want to differentiate with respect to y, you treat x as a constant. Okay, so let's see, x here you substitute with 2 lah. Okay, so now you say x is equal to 2. So because 2 here is a constant. Okay, so it's become 3 times 4 is 12. Okay, so when you differentiate 12, is equivalent to 0 because 12 is kind of a constant value. Okay, so that's why here is become 0. Okay, but for the second term, you have x, you have y, but you want to differentiate this function with respect to y. Okay, so how to do? You treat x as a constant. Okay, so when you treat x as a constant, you bring together with these two. So it's become 2x. Okay, so now you can differentiate y. Okay, so when you differentiate y is equivalent to 1. So you have 2x times 1. So it's equivalent to 2x. Okay, so once you already know this one, you can skip this step. So you just write down 2x, something like that. Okay, okay or not? Clear or
Thanks.
not? Okay.
Yes, please.
All right. So let's look at the example here. Okay, let's look at example 1. Find the value of df over dx and df over dy at point 4 minus 5 if your function is equivalent to x squared plus 3xy plus y minus 1. Okay, so how to find the value here? Okay, so if you are given a coordinate, okay, means that you have to differentiate and then you substitute with the coordinate given. Okay, because here it asks you the values. Okay, so for example, we do it one by one. Df over dx. Okay, first of all, you want to differentiate with respect to x. Okay, so the first term, you differentiate x, you will get 2x, correct? Okay, so this one you have y, but y you treat as a constant, so it's become 3y. Okay, so plus differentiate y. Y now become constant already. So when you differentiate y, you get 0. Differentiate -1 also you get 0. Okay, so finally you just only have this value 2x plus 3y. Okay, so let's look at when you want to differentiate with respect to y, dy. Okay, so how to find partial derivative? Df over dy. Okay, so df over dy is equivalent to, okay, this term didn't have y, so you treat x as a constant. So this one automatically become 0. Okay, but this one have term y, but x now become constant. So differentiate y is equal to 1. So you only have 3x here. Okay, so differentiate y, you said just now, is equivalent to 1. Differentiate negative 1 is equal to 0, right? So the answer is only 3x plus 1. Okay, so from here, you substitute. Okay, because we want to find the values df over dx at point 4, negative 5. Okay, you know that this 4 is for x, this negative 5 for y. So is equivalent to 2 multiplied by 4 plus 3 multiplied by minus 5. Okay, so from here is equivalent to minus 7, isn't it? Okay, so now find the value df over dy at point negative 5. So 3, 4 plus 1. Okay, because there is no function y here, so you just ignore the y value. Okay, just substitute for x. So 4 times 3 is 12 plus 1 is 13. Okay, so these are the values when you substitute the partial differentiation at point 4, negative 5. Okay. Any question for the first example?
Miss, is that the value of the gradient for the graph?
Yeah, for this one, I can say that let's say you have the function of this function. Gradient is dy over dx. Yes. So if you find the gradient, also is equivalent to the partial differential.
Oh, okay. Thanks, Miss.
Okay. Alright. Let's look at question number 2. Okay, example number 2. Okay, we still are using the same method. Okay, so when you want to find df over dx, you let y as a constant. When you want to find df over dy, you let x as a constant. Okay, so let's look at example number 2. Okay, example number 2, you have x squared. Okay, or you may open the bracket first, x squared y. Okay, plus 2xy minus y plus minus 2. Okay, so from here, you differentiate with respect to y. Okay, so differentiate y, x become constant. So you have x squared. Differentiate constant here is become 0. Okay, differentiate y here, you have minus 1. Differentiate negative 2 become 0. Okay, so the answer is x squared minus 1. Okay, so now let's try differentiate with respect to x. So you have y become constant. Okay, so y become constant, you put the value of y. Okay, differentiate x squared become 2x. Okay, so plus differentiate x here, you have 4x. Okay, differentiate y. Y now become constant. Okay, so differentiate constant 0. Okay, so the answer here is 2xy plus 4x. Okay, so let's look at question example 3. So x cubed plus y over 2 to power of everything to power of 2 over 3. Okay, so how to differentiate with respect to y? So you have 2 over 3. Okay, write down everything inside the bracket. Okay, 2 over 3 minus 1. Negative. Okay, multiply inside the bracket, you differentiate with respect to y. So this term becomes 0. This term is equivalent to 1 over 2, isn't it? Okay, so when you simplify, it's become 1 over 3 x power 3 plus y over 2 power of negative 1 over 3. Okay. Correct not? Okay, so for df over dx, df over dx, so from here is equivalent to over 3. Can you please try together? Okay, so that I won't do any mistake here. Okay, now differentiate everything inside the bracket with respect to x. Okay, so this term didn't have x, then you left empty. Okay, this term you differentiate x power 3 become 3x square. Okay, so from here you can simplify. So it's become 2x square x cubed plus y over 2. Okay, can you see down here?
Yes, Miss.
Yes, miss.
Okay, can someone do for this example 4? Okay, it's same like previously the one that I show you e to power of u, e to power of x. So now how to do the partial differential with respect to x and y? Anyone want to try?
I think just e power 2.
E to power of 2.
E, e only. E only.
E only. Okay, so E, you write down everything inside the bracket, right? Okay, and then differentiate, multiply, you differentiate Y. Okay, so you differentiate become 1. Okay, so the answer is only this one. So E to power of X plus Y plus 1. Okay, same goes to X here. You differentiate X, is only 1 here. So you have E x plus y plus 1. Okay, any question? Okay, so if not that, let's continue. Okay, so this one just now is only a single terms. Okay, so you only have this single one. But what happen when you have two terms? Okay, two function, and then the function you should multiply. For example, here, okay. Okay, so you have a function of A and B multiply together. Okay, so this one, if you want to find the partial differential, you have to use a multiplication rule. Okay, so what multiplication rule say? Okay, so you have A differentiate B plus B differentiate A. Okay, so this one is the notation for the differentiation, first degree of differentiation. Okay, you can say that A, okay, you have A, you have, you have A, differentiate B, same like this, okay, plus B, you differentiate A, differentiate A. Okay, so if you, this is in a simple form. If you want to remember the multiplication rule, so it's become A differentiate B plus B differentiate A. Okay, so what is A? A is the first term that you have. Okay, if you normally you will put in a bracket. Okay, so in a bracket, so you can treat as your A. Okay, the second bracket you can treat as your B. Okay, so if you want to find the differentiation of Y, so you just change the differentiation to Y. Okay, this is the same form. Okay, you want to differentiate here is either you differentiate whatever your function of B have. Okay, so let's say X here. Okay, you have a function xy equal to 2x plus 3y. Okay, multiply by 5x square plus 2y square. Okay, so now this is your A and this is your B. So if you want to differentiate, okay, so find df over dx, for example. Okay, so A you treat as a constant. Okay, you write down it back. Okay, but you have to multiply B. Sorry, you have to differentiate B. Differentiate with respect to X because inside the B, okay, so B is in term of a function of X. Okay, so you have to multiply with the differentiation of B with respect to X. Okay, so differentiate here you have 10x, okay, plus differentiate y you treat as a constant. Okay, so when you treat as a constant, so differentiate constant becomes 0. Okay, so here you can have multiply here become 20x square plus 30xy. Okay, so this is how you do the multiplication operation of two function. Okay, in finding the partial differential. Okay, do you understand?
Miss, we still have another part, right? For the f and x one. Yeah.
Again?
We still have another part, right? For this, for your solutions. You just done for the A and first part.
Yeah. Okay, thank you. Okay, so plus B, which is 5x square plus 2y square. Okay, so B here become a constant. Okay, so multiply with A with respect to X, then you have 2. Okay, so from here you have 20x square plus 30xy, okay, plus 10x square plus 4y square. So this is your df over dx. Thank you. Okay, let's look at another example. Okay, so this one, example, find df over dy if function xy equal to y sine xy. Good. If this case is not given to in a bracket, so you have to determine by yourself. Okay, so by look at here, so you can note that this is your A, and this is your B. Okay, so this is A, this is your B. Okay, remember that this one is the multiplication. So if multiplication, you may use this one. AB prime plus B A prime. Okay, so here you can have, let's say you want to find df over dy. Okay, so A, write down everything here. So A is y, differentiate B. Okay, differentiate sine xy. So what do you get?
Sine x,
Cosine xy
xy,
multiply by differentiate xy, right? So differentiate xy with respect to y, you have x. Okay, so plus b, which is sine xy. Okay, multiply with differentiate a with respect to y. So differentiate a, you get 1. So from here, you will get xy cosine xy plus sine xy. Okay, so this is how you get partial differential of function with respect to y. Okay. Okay, so you can see here, it's more clear step by step here. Okay, so basically it's the same thing lah. Okay, so let's do for the rest of the example. Okay, so look at example 6. E to power of xy multiplied by ln y. Find df over dy. So from here you can treat this one as your A, this one as your B. Okay, so we know that you can use this equation AB prime plus BA prime. So A is equal to E to power of xy multiplied by ln y. So now you want to differentiate with respect to y. So differentiate ln y become 1 over y. Okay, so plus ln y multiplied by A. Differentiate E xy. Remember that everything inside the index here, you have to differentiate with respect to y. So when you differentiate y, x become constant. Okay, so you write down constant here. Okay, so this is your answer. So you can simplify 1 over y e to power of xy plus x ln y e to power of xy. Okay. Alright. So now, can you continue with differentiate df over dx? Can or not?
I try to.
try to answer. Hello, ma. Hello, ma. Hello, ma. Hello, ma.
Anyone get the answer?
Hello, ma. Hello, ma.
My answer is ln y times y e power xy.
Okay, so correct. So I can write down like this: y ln y e to power of xy, isn't it? Okay, so you may check later how to get this value for those who are still cannot get the answer. Okay, do it one by one, like I showed previously. Okay, let's move to example 7.
Can you hear me, ma?
Okay. So like this, we can treat this one as your E, and this is your B. Okay, so E to power of negative x, differentiate B. Okay, differentiate sign. So it's become cosine, isn't it? Cosine. So write down everything inside the bracket. So you have x plus y. Okay, so plus, sorry, differentiate y, you get 1. Okay, plus sine x plus y. Okay, differentiate e minus x. Okay, so this one is x, but you want to differentiate with respect to y. So this one become 0. So everything here is equivalent to 0. The only answer that you have is e to power of negative x cosine x plus y. Okay, so let's differentiate with respect to x. So you have e to power of minus x cosine x plus y multiplied by 1 plus, okay, sine x plus y. So now you differentiate e to power of minus x. So it's become negative x. Negative e to power of negative x. Okay. Okay, so this is the answer. Alright, so example 8. Can we move to example 8? Any question on example 7? Can you do?
No, miss.
Okay, so I hope that you can do slowly. Okay, but make sure check again. Okay, to reduce the mistake during the calculation. Okay, so let's look at example 8. Okay, so x to power of y. So we know that in this function, x and y both are variable. So how to, what method that we can use to solve this problem? Okay, so let's say you have a function, okay, that has two variables, x and y. But here, the function is x to power of y. Okay, so this is the special case, okay, where you use the equation for differentiation for a to power of some things. Okay, so here previous student they learn this one in calculus, but a new batch of the student didn't take any calculus. Okay, so this one you can refer also in the calculus books. Okay, you may found under what we call this one, power rule. Okay, so this one you can refer under power rule. Okay, so what power rule said? For example, here you have d over dx to power of x to power of n. Okay, so here how you solve this equation by n x n minus 1. Okay, this one the power rule for the rational power. But if you have n here is a constant value, but y here is a variable value. Okay, so how you can use this one, how you can solve this problem. Okay, so there is another one where you have d over dx, so x to power of u. Okay, where u is the variable. So from here you have a, sorry, we use okay. Okay, so let's say you have a to power of u, so au ln x, sorry, ln a du over dx. So if you have function x to power of y, okay, so you may refer to here. Now let a equal to x and u equal to y here. Okay, so how you can solve this one? So you can have a, which is your x to power of y multiplied by ln x multiplied by du du over dx. Okay, so du over dx here is equivalent to 1, isn't it? Okay, so from here is equivalent to x to the power of y ln x. Okay, so this one is to find dy over df over dy. So if you find df over dx is a normal one, okay, so you can have x, you can use this one. Okay, so x to the power of y, so you have y x y minus 1. Okay, so this is how you differentiate with respect to x, and this is how you want to differentiate with respect to y. au ln a du over, sorry, this one supposedly to be y. Okay, so this one you can refer back the power rule for the rational power. Okay, so here is the fixed formula to solve for dx over dy, right? Okay, so any question on this example? Okay, so if not, then let's look at this quotient. Okay, so we call this one as a quotient rule. Okay, so this one is the quotient rule. So we look at how we can find the partial differential if we have a quotient function. Okay, so this one you can use this formula. Okay, so if this one, this is your A, the denominator is your B. Okay, so if like this, we can have B differentiate A minus. Okay, if multiply just now, we have plus, right? So if a quotient rule, okay, if you have this quotient function, okay, so you have to use minus. So minus differentiate B, okay, over B square. Okay, so you just remember this one. Okay, so if you want to find the partial differential with respect to x, then everything you must have in differentiate in x. Okay, if you have a y here, df over dy, then when you differentiate, you must differentiate with respect to y. Okay, but the formula is this one, b differentiate a minus a differentiate b over b square. Okay, so if we have plus just now, a b, okay, a b plus b a. Okay, so it change with this one. Okay, this one we start with denominator first, multiply by a, differentiate a, minus a, differentiate by denominator after you differentiate. Okay, over b square. Okay, so let's look at this example. So we have this one is a, this one is b. Okay, so we know that in order to solve this one, so we have b differentiate a minus a differentiate b over b square. Okay, so from here, let's say we want to differentiate with respect to x. Okay, so we have y plus cosine x. Okay, differentiate 2y. 2y, y you treat as a constant. So when you differentiate constant, it become 0. Okay, so minus 2y differentiate b. Okay, differentiate b with respect to x, but y you have 0. Okay, cosine x become sine x, isn't it? Negative sine x. Okay, over b square. So y plus cosine x square. Okay, so when you simplify, this term is already 0. So you have 2y sine x over y plus cosine x square. Okay, so it seems like you want to find df over dy. df over dy. So you have y plus cosine x. Okay, differentiate a. Okay, with respect to y. So you have 2 minus a, which is 2y, differentiate b with respect to y. So cosine become 0. Differentiate y is equal to 1. So over, okay, over y plus cosine x square. Okay, so we simplify, then become 2y plus 2 cosine x minus 2y. Okay. Okay, so now you can simplify, right? So this one 2y minus 2y, so it's become 2 cosine x over y plus cosine x. Okay, so this is your answer, 2 cosine x over y plus cosine x square. Okay, so this is example 9. Okay, you may refer back to here. Okay, but finally we will get the same answer. Okay, that same answer differentiate df over dx and df over dy. I said the same answer with the one that I calculate here. Okay, you may refer back. Okay, so next, what else? Okay, so we have another example here. Example 10 and 11. Okay, so let's look at the example 10. Okay, this one also kind of a quotient rule. Okay, so your A is equal to 1, your B equal to x plus y. So same thing lah. Like previous example, I use B differentiate A minus A differentiate B over B square. Okay, so remember this one. Okay, so df over dy. So x plus y. Okay, differentiate A. So it's become 0 because your A is equivalent to constant, right? Okay, so minus 1 multiplied by differentiate x plus y with respect to 1. You have 1. Okay, over x plus y. So if you simplify, it's become x plus y square. Okay. So if you differentiate with respect to x, also same lah. Okay, so x plus y differentiate x with respect to x is become 0 because this one is a constant value. Okay, so this one also you will get the same answer. Okay. Okay, example 11. 12. Sorry, example 11. Okay. So this one, x square plus y square multiplied by x differentiate with respect to y. So 0. Okay, minus x square plus y square. So differentiate with respect to y. So you have 2y here. X square plus y square. So it's equivalent to negative x, negative 2xy over x square plus y square. Okay, so df over dx here is equivalent to this one differentiate with respect to x, you get 1. So you have x square plus y square minus x multiplied by 2x. So it's become x times over x square plus y square. Okay, so x square minus 2x square. So it's become negative x square. Okay, so this is the final answer. Can you check? Is it same with your answer?
Yes, the same.
Same.
Okay, so if same, then I think you can understand, right? So this one is quite same, like not so tricky. Okay, so this one is just a normal differentiation. Okay, maybe the additional thing is about the multiplication rule and quotient rule. Okay, so how to find the partial differential. Okay. Okay, so I think for today is enough up to partial differential. Okay, so next class we will continue with the multiple differentiation. Okay, so multiple differentiation and implicit differentiation. Okay, so it's quite different with the partial differential. Okay, so if you still go back, okay, try to do some example on this partial differential. Do again all the exercise that we made just now. Okay, make sure you really understand how to do the partial differential. Okay, because next class we will do on the implicit differentiation. Okay, so if this one we let if we want to differentiate with respect to x, we let y as a constant, but in implicit, okay, so it still can be differentiable. Okay, so there is no way to getting a zero answer. Okay, so you still can able to differentiate. Okay, let's say when you differentiate constant, so it's become zero, right? But in implicit, okay, in implicit differentiation, it's still you still able to differentiate it. Okay, so make sure you yourself practice a lot on this partial differential. Okay, so that later on you're not confused. Okay, when we go on the implicit differentiation, you're not confused with the partial differential. Okay. All right. So any questions?
No, miss, no questions.
No question. Others?
No, ma'am.
Okay, so again, I want to highlight here, if you want to find the lecture note, okay, so you may refer to the theme, okay, in this subtopic. Okay, so for example, in for the topic that matrices that we learned previously, you may go to the file and find the lecture slide and recorded lecture video here. Okay, so for chapter 2, okay, partial differential, I will put into this column lah, so that you can see the subsection of the lecture. Okay. Alright, so I think our tutorial already start by last week, right? So should be continue on this week. Okay, so for those who just join, who just enter this course, please make sure that you read the introductory slide. Okay, refer to the my post in the beginnings. Okay, so that you won't left anything, especially on the tutorial session. Okay, so make sure you enroll one tutorial session that are very suitable for your timetable. Okay, and join. Tutorial is once a week, and lecture class will be twice per week. Okay, so our time is following the Malaysia time. Okay, because I'm currently in Malaysia, so I'm following the Malaysia time. Okay, so please adjust your times. Okay, so Monday 3:30 and Wednesday at 12:30 noon. Okay, so please aware on this time. Okay, I don't want you to miss the class because you are following your home country time, right? Okay, so if no more question, I think we can stop our class here. Okay, hope to see you again for the next class. Okay, all right.